This is Karalin Czapski for instructional video number 2. I got problem number 33, which 33 is create a rational function f with vertical asymptotes at x equals 0 and x equals negative 5 and a horizontal asymptote at y equals 0. So first we're going to start with our rational function, which a rational function is a polynomial over a polynomial where a denominator does not equal 0. So we are going to set up our function f, where f of x is a fraction at this point. So vertical asymptotes. Our vertical asymptotes is x equals 0 and x equals negative 5. Vertical asymptotes are vertical lines that correspond to the zeros of the denominator of a rational function. Whichever values are not allowed in the domain will be vertical asymptotes on the graph. In other words, domain and vertical asymptotes are opposites. So we need to make our vertical asymptotes where we have to find what negative 5 is a factor of and also what 0 is a factor of. So we have negative 5. So negative 5 is a factor of x plus 5, and also where x equals 0. So that's just going to be x. So now we have to find our horizontal asymptote, where our horizontal asymptote y equals 0. Horizontal asymptotes are horizontal lines that the graph of the function extends forever to the left or forever to the right. If the degree on the top is less than the degree on the bottom, then the horizontal asymptote equals 0. So our bottom degree, our bottom degree is 2. So we need our top degree to be less than a degree of 2. So then we'll place x on the top. We can't just leave an x in the numerator because the x will cancel with the x in the denominator, which causes a hole in the graph. So to balance out the graph, we could place in x plus 1. So we are left with a function f of x equals x plus 1 over x squared plus 5.